Hello, everyone. Before we start, let me ask you a question. Have you ever felt that architectural design is a torturing process? Have you ever felt that you shouldn't have chosen this career path? If you have, this thesis may give you some insight. Nowadays, with the rise of artificial intelligence, the architectural field is facing great change. Therefore, this thesis aims to explore the relationship between AI and architecture. It is commonly observed that the process of design is often a frustrating process, while needing to evaluate the design is another abstract and difficult task. Therefore, the vision of the thesis is to develop an AI architectural design machine that could allow AI to perform both the design and evaluation task instead of heavily relying on humans. However, we still need an architectural topic to be the testing object, and the topic is urban renewal in Hong Kong. Urban renewal is often a popular and urging topic in Hong Kong due to multiple reasons. First, there are numerous old tenement buildings that were built in the 1950s and 1960s. They have serious structural decay and safety issue, not to say their condition can no longer meet modern standard. Also, Hong Kong has a severe land scarcity that more space is needed. As a result, urban renewal is a primary tool to fix these problems while improving the city's living standard. Nevertheless, the Hong Kong's Urban Renewal Authority's approach in implementing redevelopment is questionable. The URA's most common approach is to fully demolish the whole site and build a new podium tower on it. Therefore, the two situations, the existing old tenement buildings and the fully redeveloped podium tower, have formed two extremes, the 0% redevelopment and 100% redevelopment. The old buildings fail to meet modern living standards, yet the new podium tower has totally neglected the cultural preservation of Hong Kong's unique old building types. Therefore, the thesis aims to utilize AI to discover the in-between possibility between the 0% and 100%. One traditional way of redevelopment is to build a pencil tower on top of one lot of tenement buildings, yet this way is considered ineffective as the tower is too thin. So, we have come up with a new idea of redevelopment. Instead of extending upward from just one lot, we use multiple or even all lots in the same site to perform upward extension, so there would be more volume to create space to meet modern need. The specific site that we choose to be the testing ground of the thesis would be Yau Ma Tei, an old district in Hong Kong, where there are full of old tenement buildings. We divided the site into 35 smaller sites that each of them is an experimental object for this AI architectural machine. So let's officially introduce the AI machine. Basically, we use programming to develop a software that Flutter and Python are used as the main developing language. AI design is often regarded as arbitrary, yet this machine aims to solve the issue. In the design part features, users can upload an image of an old building site to the interface, and they can type in their custom design prompt to create new design. Moreover, the application provided a myriad of fine-tuned design tools to allow users to perform more controlled design strategies so that we can prevent having arbitrary results. Bear in mind that the machine mainly focuses on the form and massing of design. The blue massing stands for the new upward extension, while the green massing stands for the new communal space. Under this system, a wide range of design iterations can be generated effectively. Nano Banana would be the main AI engine to facilitate the function due to its strong image editing capacity. Additionally, Superbase is used as the technical tool for database and storage. As numerous designs are generated, evaluation is required, and we hand this task to AI as well. This idea is interesting as we, as architects, often rely on our knowledge and experience to do evaluation. But now, even this process can be handled by AI. In order to achieve this evaluation function, we cannot just use ChatGPT or Gemini, as these regular AI tools lack accuracy and consistency. So instead, we need a vision language model, so-called VLM, that in definition is an advanced AI system capable of understanding and processing both visual information and textual information simultaneously. In nowadays, VLM is commonly used to distinguish diseases in medical field or used to identify disasters by the satellite, but now, we utilize it for architectural evaluation. To fit in with the context of urban renewal, we have established 3 critical evaluation criteria to score the designs. First, it is porosity index, that it evaluates whether the design is porous enough to allow light and air to flow through in such a dense site like Hong Kong. When the VLM detects more voids and gaps within the image, it gives a higher score. Second, it is developmental viability, that it evaluates whether the design shows a feasible geometry to be built in real world. When the VLM detects more orthogonal shape and a structurally feasible form, it gives a higher score. Thirdly, it is communal space quality, that it evaluates whether the green space can provide vibrant and convenient area for the public to engage, and a tier will be given to grade the design. To train the VLM, I have used 80 datasets in total. Each dataset is a design iteration with its respective scoring and reasonings, and they are all fed into a platform called Replicate to train a VLM. Afterwards, the VLM is put inside the machine we developed. As a result, we can perform more accurate and consistent architectural evaluation to the designs we generated. The evaluation result is represented on a graph. The design that is closer to the top right-hand corner means that it has the higher score in terms of porosity index and developmental viability, and by seeing the color of the frame, we can also see the grading of communal space quality. Therefore, by going back and forth between design and evaluation, we can gradually obtain a more optimized design approach. Additionally, by putting all the design results on a master mapping graph, we can easily tell which design stands out among the crowd and adapt it to for usage. By applying this AI design machine to the sites in Yau Ma Tei, we can flexibly target the specific location we want and perform redevelopment to it. By repeating this process, we can perform large-scale urban renewal to the site and make drastic transformation. This architectural AI machine has shown its unique capacity in terms of performing urban renewal design, and somehow offers some inspirations of exploring between the 0% and 100%. Before, creating a design could really take time, but now with the aid of AI, it is just a few clicks on the screen. This thesis does not only show how AI has grown to be more capable, but also reveal to us the immeasurable potential that it can accomplish in architectural design. We as architects may be proud of our skills, saying that AI is not a threat to us. However, back in the 18th century during the Industrial Revolution, people also claimed that machines cannot replace humans. See what happened next? History keeps repeating itself. Anyway, let's wait and see what kind of future the tide of AI is sweeping us toward. I am not so sure too. This is the end of the video. Thank you.